Okay, probably we shall start. Can you hear me well? Okay, so if you have any questions, don't hesitate. Raise your hand and we will go through it. So thank you for coming. Thank you for registering for my course. This is my first time teaching here in Skoltech. So this is the course titled Foundations of Software Engineering. And I'm your instructor this year. My name is Alexander Mikhailev. So just a few slides about me. I got my PhD here in Russia in Institute of Numerical Mathematics, although I studied in Moscow State University, both in PhD program and when I was getting my master degree. So you're here in Skoltech and you know this problem when you have to defend yourself in some other entity just to get degree that counts in Russia. But recently this was changed. So good news, you don't have to find any other institute where you will have to defend your PhD just to have it working in Russia. Okay. So then I was working here in Skoltech as just software developer on a joint project with Huawei. And as you see, then I went out and I got several positions outside Russia. Namely, the first one is in KAUST. It is King Abdullah University of Science and Technology. It is located in Saudi Arabia, and there I was working on parallel programming and so on. So I was a postdoc there, and the department was called Extreme Computing Research Center. So I was working on supercomputer, on parallel stuff. Later, I moved to Germany, and I was working mostly on mathematical aspects. And also I was, let's say, improving certain code, outdated code that was written by chemists in a very bad fashion, I would say. And lots of, if you're a programmer, you know that it is not so good to use global variables and so on, but those people, they don't care. They just, there is a method, they need to implement it, they create executable, everything is done through executables. That's it. You provide input file, you get output. Don't care, they don't care what is inside program, how it is written. So I was working on reworking their software a lot and improving, of course, scalability and other aspects, readability, documentation, testing. So things that I will be talking here in this course. And now I'm senior research scientist here in Skoltech, and you can have more info about me by the link. This presentation itself, I believe it is shared already on Canvas. So at 9 o'clock, it shall be available with all the lecture materials. You can open it, get a look, and just understand what we are working with. And this is the idea of the course. You come here, you listen, we discuss certain things, you ask something probably, and I answer or do not answer because there are things here in this course that I'm not a professional. So I simply mean there are many tasks that we need to develop, we need to solve, and these tasks can be solved in many different ways, and it's not always done in a single way. Single way is, there is no perfect way. You do it as you do it. Now, why do you need to learn software engineering at all? So here, we're doing a lot of programming, and this is the main reason. So if you would like to share your work with others, and let's say you're a mature scientist already, and you have some nice method, you would like to write a paper, you already have it, and you want to spread it such that people compare against it. People use it as baseline. This is the total goal of scientists, for their methods and software to be used. So if your method is simple, which is like 99% of all the research, then what else can you do? Use shell, optimize user experience. This is normal. Otherwise, if you download some software and you just don't understand how it works, then you just drop it. The same with science. If you don't understand it, I mean, at least software, and at least you cannot reproduce whatever was done, then it is just a total trash, and that's it. I believe you all have written your programs for several years. So if you take a look for a program that you started 5 years ago, 100% that you will not understand whatever you meant in certain lines of code. And it's just like that. Even yourself, you cannot understand sometimes whatever you meant. So idea of the entire software engineering is to make not only you, but others understand. So first of all, you need to press on quality, not on quantity of software. If we are talking about science, then most research in data science, it is just programming. As I already told you, sorry. You have a nice idea, which is usually just a simple idea. And to tell the world that this simple idea works, you need to present your computational results. That's why other people need to reproduce them. Nobody wants to re-implement your code. And it's like not only in data science and also in machine learning. All the efforts are put on software engineering, such that others could just download, install, put their data in and get some results as fast as possible. Okay, next step, as you can read here. Yes, please. Okay, there will be no link to the Zoom because my license, I got it from Germany. It is still working. So due to sanctions, all other ways to record video, they just do not work here. And I had to use my license that could expire anytime. So going further, if you are working in parallel, I mean, on parallel programming, your method works, you need to make it fast, you go parallel, you try to use other hardware. This is where even more software engineering comes in because users, they have totally different setups, totally different GPUs, totally different CPUs, totally different libraries that you use. You need to gather all the information. It's not that you have access to JRS. You just tell, okay, from JRS, I use this, and it works. It just simply means that others will never use your software. Others, I mean, others outside Skaltech, those who do not have access to JRS. So all the effort is on the software. And the last reason is, of course, that my other colleagues, they told me that some students, they come, they approach them and tell, okay, we would like to work on some project for master thesis, but we never worked on that, and so on. And such students, they don't have experience in teamwork, and they just somehow ruin certain aspects of teamwork. I mean, mostly version control. So when you develop something together with your supervisor, you need to take a look who is working on what and solve certain problems. And it is possible that you or your supervisor break something. So to reduce possibility of such a thing, you need to be aware of all the tools and to make your code reproducible, not only on your side, but also on supervisor's side. So it is about reproducibility even during development. And we will talk about that a lot. So this is why we need to study this course. Okay. This course will just show you certain tools that we might use during our work, but it is not, you're not obliged to learn it by heart, because here in software engineering, you cannot simply learn some formula, some equation, and that's it. You have to practice a lot. practice makes perfect. You need to write scripts, you need to write tests, you need to use a lot Git, for example, for version control, because you will be developing a lot, developing and programming a lot. You need to push your changes to some cloud repositories, to cloud server, such that others could grab it and play with your changes. So goal is to show you ideas and tools. Your goal is to play with such tools and repeat it a lot, and by practice, learn it. So as you can see here, we will study certain things about building software, working on development, writing tests, and of course, the last thing, building Docker images here. It is for reproducibility. Docker is just a standard way to ship your program to other environments, to other users, without doing simply without doing anything. Docker does everything for you. You need to learn how to use it. And then working with other software will be very easy. So this is our timeline. So this week we are studying a local machine. So we're working on Unix fundamentals, Linux fundamentals, certain tools of Unix programming. I mean, not programming, of course, but terminal commands, shell commands. And we'll finish this week with with version control. Sorry, need to take a little break. Sorry for that. So I have some problems talking a lot. So we finish this week with version control. Here we cover how to work with others with help of Git tool, Git software. I believe most of you heard of it and using it a lot, but in any case, we need to go through it. Second week is for the, as you see, it is remote machine, because here in Skoltech, you have access to different clusters, different remote machines where you will launch your programs instead of your laptops, because we have workstations that are much more performant. You need to get access. You connect, you launch some old code, some new code, and you get results. We will study how to do that. Then we will talk about building software, how to automate this process instead of having a simple script, as probably many of you do, because I was doing when I was a student, just a simple script that compile this, compile that, then next step, gather everything. We will learn how to make it in a better way. And we finish next week with the studying what are the reproducibility aspects and how to work with Docker. Week 3 is about, as you see, testing software, how to write tests for Python, for example. Then we'll try to debug certain programs, learn how to do it in an interactive way with help of Python debugger or GNU debugger. And we finish week 3 with so-called deploying software, where you learn how to, for GitHub, how to create a runner which will run your code. When you push something to Git, for example, you push to GitHub your changes, they will automatically launch certain steps on some server. So this server will collect all new changes. It will build them using your build script or build system that you use, and it will try to run tests. And then it will tell you if everything was fine or not. So with a simple click of a button and waiting, of course, you will see result that your software failed or your software succeeded. Everything is fine. No need to fix anything. And if it failed, you will see where it failed on other machine, not only on your local machine. This is first step in deploying, in giving some others access to your code. Usually it's called continuous integration or continuous development. And last week is working on project. For this, okay, we will talk about project later. So you have entire week working on project in teams. This course is a pass or fail. So your final grade or final pass is decided on this scheme that is above me. And it is mostly based on your final project and computer labs. So computer labs here are just homeworks. You do it in groups of 6 people. So I believe that you all see in Canvas that you're in some random group of 6 people. Today you will gather together, do certain first steps of the computer lab, and then somehow you will proceed. So you need to push your results. So there is an assignment for each computer lab. One of you from each group will have to just submit whatever is needed, and we will check. So grading is not done like correct or not, because certain tools in different environments, on different Linux flavors, on different distributions, they will give you different answers. All the comments, they have slightly different arguments. So we all have systems. I see many of you with Windows. So if you install Windows support for Linux, I don't know how it is called, so I just heard it yesterday, then probably your comments will have certain input arguments, the tools that we will study. For Mac books, for Mac OS, they implemented the same tools in their own way. So result is incompatible. This is the main problem. So I just suggest you installing some version that you are working with and telling us what is your environment, and then publish all the comments that you need for the computer labs. So for the computer labs, you will need to just publish comments, how you call certain tools with which parameters to acquire, to get required results. What else about computer lab? So if you just submit it, it counts more or less as if you did it. So we're not checking full correctness. Sorry. So I propose all of you in every group for the computer lab just to play on your local machine with whatever you submitted. Do not submit empty list, because of course empty list counts as failure. You need to do certain work to understand how to solve problem and present a way to solve it. If a way to solve the problem is more or less okay, looks perfectly fine, then it will be counted as full grade. No pressure on you, but you need to practice yourself on your local machine, wherever you have your shell terminal, and practice it, because only practice can help you. For the final project, you will need to gather again in groups of 6 people, but this time it is not random. You decide which group you are. So I will try to understand how to do this through Canvas, such that you could register your groups. And then up to a certain deadline, I will talk about this later, not today. You will just tell me what other code you would like to play with, to improve, to apply all the knowledge that you get here. And then you just submit your final result. So usually it was, previous years, it was done through GitHub repositories, but let us do it also through GitHub this year, but do not use your Skaltech related email. Just register, try to register random account with random Gmail, and let's play it like that, because IT didn't set up our local Git yet, and where I don't have access to any Git that I can give you. So Let us play with GitHub. Yesterday I checked. It is impossible right now to register a new account on Bitbucket, another big cloud for Git related things. So let's hope that GitHub works. Okay, 20% of your grade is test and quiz. For every test and quiz, you will have like 60 minutes to answer around 10 questions. You have just enough time to find your answer on the internet or within materials of the lecture. No pressure on you. Before posting answer, try to play with this answer in your shell terminal and then just put it into the quiz. So it's also not so hard to get full grade or nearly full grade. For final project, way to assess your grade will be published later. So we have certain steps that I and my assistant will be just checking step by step, whatever you have in your software, and we will check all of this and put a grade depending on that. Okay, now to whom this course may concern. So if you are a professional Unix or Linux developer, of course, this course is not for you because it is too naive, too simple. We are not going into details. We're just showing whatever tools you need to learn. I mean, learn by name. So this tool does this. Okay, what are the parameters? Google these parameters. So search for them in manuals. Then you can use it. That's it. This is the idea of the course, to tell you there are such tools and each tool can do its job. What is the job of this tool? Since here in data science, you are going to work a lot in Linux or Unix environments, that's why you need to take this course, as I already told you. So you have a week to drop off week, so you could decide if this course for you or not. So even if you're a professional developer, then you're getting free credits for free. I would say it is just, why not? So in this course, we're not learning how to program, how to manage your team. We're not talking about some methods that we will study in other courses. We just do very simple things with standard tools. Every task that I will ask you to do can be performed, of course, with help of C++, C, Python, Perl programming languages, scripting languages. But we are talking about certain tools that are already there, and you can solve many problems in just a single line. Instead of writing some script, Python script, which you are 100% sure that it works, and so on, we'll solve the same problems with help of single line command. And as I told you in the beginning, I am not aware of many of such things because I myself prefer Python programming language, Python scripting language, whatever you call it. And many years ago, when I myself was a student, for everything that I needed to do, I was just writing Python script. Later, I learned there are other tools, much simpler tools. And okay, it's just up to you to decide, but these single line commands, other software developers, they more or less will understand them. And since these are single line commands, just why not use them? It will accelerate your product. It will just improve your production speed. As I'm talking about all of these things, it's just practice. Practice makes perfect. We are not talking about theory a lot. We're mostly spending time in practice here in this course. There will be lots of dumb tasks to do. So course project, as I already told, you gather in teams of 6 people. You tell me what is the crappy repository of your choice that you would like to improve, what is your playground. And then as output, you give us, just create repository with something crappy. I mean, there is no build system, so it is really hard to compile your code, to just run tests, just to visualize some results. And as output, I will get some GitHub history of how you developed it. I will see how many people actually took part in developing. I believe that all of students, so everyone in the group shall do something. So you will create a new build system or rework existing one, add some tests. Of course, you will find some bugs and you will resolve them, and you will package it in Docker such that I will run it on Windows machine, on Linux machine, or on my Mac laptop. So any questions? So yes, please. So once again, you may take this course and you're getting 3 credits for free. It's just good enough, I would say, to stay here. And if you already know all of these tools, it will be easy for you. And it's like, to be honest, I do not care that much because you already learned all the tools by practice. But the idea is to show others to use Google or Yandex to search for answers, to type all these answers in a terminal, to see what is the output. It's just a playground. We're playing with software. I'm not saying that you shall leave this course. Okay, so now please, you all have access to entry poll. I believe so. It is in Canvas. So please take a look at it and let's spend some time answering it. So let's wait like 3 more minutes and okay, let's find answers, take a look at them. Never used before Yandex forms, to be honest. Okay, we have first items for version control. Yes, we need to cover it. 70% of people who are coming here actually, yeah. So everything is fine, around 70%. People, this course will just tell something, you will find something new. And I just believe that it will be easier for you to work with your future supervisors. So this is the idea of this course. Now let me find all the materials you can find All the materials you can find in Canvas already. So I will open this video. I hope we can hear it. It is just telling you what is the Linux, why we need to play with it.
They don't know what it really is. But what is it? In this video, I'll cover what it is, how you can use it, software, drivers, and I'm going to touch on security and antivirus, or I should say why you don't need antivirus. Technically, Linux is just a kernel, the core component of the operating system that interacts with your hardware and various running processes. What you see when looking at desktops like this is really called GNU Linux or GNU Linux, where GNU stands for GNU's Not Unix. GNU is a free and open source collection of software. There's controversy on the whole Linux and GNU Linux naming, and both have valid points, but for simplicity, we'll just call the general operating system here Linux. The kernel, as I mentioned, is the core. It talks to your hardware and includes built-in drivers, networking, and power management, among many other things. Then, what you see and interact with are the display managers and desktop or window managers, which are highly customizable. A quick history note here. The Linux kernel was written in 1991 by Linus Torvalds. It was written to be a binary compatible clone of Unix. Linus was using another Unix-like operating system called Minix, but due to its licensing restrictions, he decided to write his own kernel from scratch and incorporated GNU programs to run within it. He then released the code to the world and then placed it under the GPL license, which allows everyone to see the source code and contribute to it by suggesting code changes, fixes, and improvements. It is still open source to this day, which allows anyone from the community to contribute to its development or even create their own versions with different features. You'll notice when seeing various Linux desktops is that there's a vast variety of how they look and operate. That's because it can be configured however you like in a very modular way, and you can mix and match whatever components you wish to use. There's also lots of theming possible on top of this as well. Common desktops you'll see are GNOME, KDE, Cinnamon, XFCE, and many more. You can also customize each of these to make them look and behave however you wish by reconfiguring them, adding additional components, or mixing and matching different desktop components together. You can even make one desktop environment look like another. Each has their own way to help manage your workflow, and none are really the best. It's just a matter of preference. So if you're looking to try Linux for the first time, it's best to try different things in virtual machines first to see what you prefer. It's also possible to install multiple desktop environments at the same time, and then you can switch between them when you log in. But what do you download to get started, and what software can you run? First of all, because of the nature of Linux being free and open source, anyone can take one version and customize it to create a new one with a different name, even you and me, provided you have the time and resources, that is. All the source code is available, so you can rewrite whatever you want, recompile it, and redistribute it. These different versions of Linux, or flavors, are called distributions, or distros for short. You may have heard of Ubuntu, and this is what's known as a distro. It's a specific collection of software packages that create the operating system and is managed by teams of developers and maintainers. There's also Linux Mint, which is based on Ubuntu, and Ubuntu is based on another distro called Debian. Here you can see how some distros are built upon others. Debian itself is what's called a root distro, meaning it is independent and was built from scratch and not built from anything else. But hundreds of distros are based on it. Each distro has their own community, forums, chat sites, etc. There's a lot more to cover on distros, but that's something I'll cover in another video. So just like desktop environments, distros are a matter of personal preference. I encourage you to try out several distros and see what you prefer. This is commonly known as distro hopping. You can even install multiple distros on your computer at the same time and choose which one you want to load when your computer boots up. This is called dual booting or multi-booting, and you can also even keep Windows as well. I made a video on this, so check the link in the description or click the link on the screen for information on how this works and how to do it. As for software and gaming, there are plenty of applications to choose from, and they're all free. All the basics you need to run a desktop are available. You have file managers, which have all the same basic functions of Windows Explorer or Mac's Finder, and they can also access USB sticks or other partitions on your computer, even if they're formatted for use in Windows. You have the familiar home directory with the usual documents, downloads, and so on, but if you venture outside of that and browse the drive, you'll find it very different from Windows. But if you're interested in that, check out my video on Linux directories explained. There are lots of media players which support almost all video and audio formats, and you can even install Spotify. You also have common web browsers such as Firefox, Chrome, Brave, Opera, and you can even run the new Microsoft Edge browser, which is currently available as a preview build for Linux. There is also a way to run an older version of Internet Explorer if you really need it. Unfortunately, Windows or Mac software doesn't run out of the box, but you can use something called Wine to install Windows software like Microsoft Office. Of course, not everything runs perfectly using Wine, but Linux has alternatives for almost anything. Instead of Microsoft Office, for example, you can use LibreOffice or OnlyOffice. These are free applications that can open, edit, and save documents, spreadsheets, and presentations in the Microsoft Office file format. Steam has a native Linux client, and their library has plenty of games that natively support Linux. Just look for this icon. And even if games are available natively for Linux, Steam has been developing software called Proton, which allows you to play the Windows versions of games in Linux. More and more titles are supported every day, allowing more games to run in Linux. Software is easy to install in Linux. It's organized in what's called packages. So Steam or LibreOffice are packages, and so is pretty much every component of the operating system. A package is a collection of file and applications. In almost every distro, you have a package manager. This is like an app store that you would find in Windows or on a Mac. Pretty much all the software you'll need is available here, and it's the best and easiest way to install and uninstall things. It's also where you'll get updates for software and security. There's very rarely any need to go to any website to download and install anything in Linux. I made a video on installing software in Linux for multiple package managers, so check the link in the description or click the link on the screen. So what about drivers for your hardware? Well, the good news is that almost all hardware is supported out of the box without a need to install any drivers. The kernel and its modules take care of all of that for you. The most common devices that require drivers to be installed are NVIDIA graphics cards, and that's because NVIDIA does not release their code for Linux developers to work with. Most distros like Ubuntu and Mint have easy ways to load the proprietary drivers if you really need that extra performance. But out of the box, the open source Nouveau drivers will work pretty well for most cards and games. If you're using a different distro that doesn't have a built-in proprietary driver installer, they usually have a wiki or some kind of instruction that will tell you step by step how to set up the proprietary drivers. Another thing I'll mention while talking about hardware is it runs great on old hardware because it uses less resources and less memory. So if you have an old laptop or desktop kicking around that is just starting to get slow and Windows is just chugging along on it, you can just format it, install Linux on it, and I guarantee you it'll run a lot better. So what about security and viruses? Well, one thing you'll notice is that people who run Linux don't run antivirus software, and there's a few reasons for that. Linux is built secure from the ground up. Your regular user account can't do much to damage the system, so any software that does get into your system can't do much. In order to access system files or install or uninstall software, your system will prompt you for your root password. The root password is what you set when you first install Linux. This password is what gives a running process elevated permissions to do things. Without it, you can't do a whole lot. Linux is also very compartmentalized, so processes only have limited permissions unless you specifically grant them. Even downloading an executable program from a shady website doesn't mean it can do anything unless you've given that file permission to be executed. This is where using the package manager or software center gives you yet another advantage of knowing that whatever software you're downloading is safe and secure. All these reasons that I mentioned are why viruses are almost non-existent for Linux. Trying to make a working virus to attack Linux is much too hard and is usually pointless. You will, however, see antivirus software that can run in Linux, but this is usually made for people who are running file or mail servers that will be accessed by Windows machines. and are intended to protect the Windows machines that are accessing those files, and not really required to protect the server itself. So why doesn't everyone use Linux if it's so great? Well, some people don't like change. Others need specific software that is only available in certain operating systems. And some people just find Linux to be overwhelming and complicated. We've all seen the movies where someone is hacking away on a supposed Linux machine that's spewing out all this code in multiple windows and someone's typing away furiously. Well, you can set up something like this if you want to, but the reality is that Linux has come a long way in recent years. It's really quite easy to install, set up, and use. Everything is all graphical menus and easy to navigate. Back in the 90s when I installed Linux, it was not so easy and needed a lot of manual work to get it up and running, but that's all changed. Perhaps it would surprise some to know that Linux is actually all around them, and they use devices that run Linux every day. Things like your internet router, printer, smart TV, smartwatch, Amazon and Roku devices, your car's infotainment system and navigation, and even your Android phones and tablets, since Android is based on Linux. It's also used in air traffic controllers, the Large Hadron Collider, and by big corporations like Lockheed Martin, NASA, and the Department of National Defense. It also powers many supercomputers and website servers around the world. As I mentioned earlier, the best way to try out Linux on a Windows or Mac computer is to use virtual machine software such as VirtualBox or VMware. Then it's just a matter of downloading some ISO files and loading them into your VM. An ISO file is simply a file which is an image of a disk and can be loaded as a CD or DVD in a virtual machine to simulate loading a disk into a real machine. These ISO files are what you'll get from any Linux website when you're downloading a distro. Another alternative is you can use a program like Rufus in Windows to write an ISO file to a USB stick. Then you can boot off of the USB stick to try the live version on your hardware without installing it, and you can see if you like it while ensuring that it will run on whatever hardware you're using. Doing it this way will also give you a better idea of how it will perform on your hardware as opposed to running it through a virtual machine. So if you're curious about Linux, I hope you give it a try, give it a chance, and I hope you found this video useful. I have plenty of Linux videos.
Okay, so I believe that this video covered some things. So many of people are afraid of Linux simply because it is a terminal, it is a shell, and it is asking something from you, and you do not even know whatever it is asking. So as you saw, you can even play games here. So you can install something yourself, whatever you like, just choose Ubuntu as a starting point. It is more or less good. It has more or less good graphical user interface, and then just proceed with it. But here we're studying how to work with terminal, simply because in your future work, you will be connecting a lot to remote servers, and remote servers, they just don't have this graphical user interface, and you will have to learn certain tools. So let us proceed. So we watched some video. You saw that if we're talking about Linux or distributions, there are lots of them. It all started long time ago, and Linux itself was created as an attempt to create something open source. So nowadays, open source is the way to go. And GitHub, Bitbucket, GitLab, they all support open source projects. Why not have some operating system that is open? So Linux is the way to go. It is publicly open. You can improve, you can add certain things in there if you would like, of course, and it will go through a certain process of approving your changes, checking if there are vulnerabilities, and so on. So as you heard, you do not need antivirus simply because all the people who work on this kernel, they just check if there are certain security issues. And if your code is just protected, then nobody could get access. However, if there is some issue in the code, of course, somebody could just use it. And recently there were problems with certain certification libraries which are not open source, and there were found some bugs inside, and let's say other people could get access to your machine. So something closed source can have bugs simply because nobody knows how properly it was tested. Open source, all the people in the world, they check code and find bugs. So there are different flavors. And as you see, even macOS system is a certain Unix-like system. And if you have your MacBook, you see that, well, we have pretty similar file system, we have pretty similar commands and so on, but it is closed source. Linux, which is under the GNU, GNU is not Unix, it is everything must be open. So their ideology, everything must be open source. There are many different distributions. It means that you have certain version of kernel, Linux kernel or Unix kernel with different additional software, tools and drivers and so on. So depending on whatever is shipped, it has different names. And you saw many lines, I believe, in the video where it's a different distributions. Each distribution simply has different graphical user interface, different predefined software. Ubuntu has everything you need in your normal work on laptop, just like Windows. That's why I'm saying that you probably might use it. Linux is used in, as it was told, also in supercomputers, simply because in Linux you can control what is the distribution. You can reduce amount of additional daemons or processes that are running in background, such that your program is getting more than 99% of CPU. For example, for Ubuntu, if you run the same code and measure its time, you will get plus minus 10% difference in total time, in whole time, simply because Ubuntu has lots of processes running in background. Special software, special operating system on supercomputers, it has all these processes just removed. Only required processes, for example, networking processes, secure shell process, MPI, if you heard of this, that's it, nothing else. This way, if you run the same program several times, you are getting less than 1% difference in whole time. This is the reproducibility that you would like to get. This is normal story, I would say. So even although Linux is open source and is free, there is still something where you pay for. It's Red Hat Enterprise Linux, simply because people are working on improving security. So they are selling this to supercomputers or some big clusters, data centers, and they working on security issues. And you're getting updates. Every distribution has its own package manager, as you see here. So this is the thing that you need to learn. There is no need to be afraid of terminal. You can install graphical user interface, even if you are on just command line. You can install graphical user interface, launch it properly, connect to it properly. That's it. You are working with it. However, if you're connecting to a remote server, you need to have access rights to install such a graphical user interface. Usually, it is not allowed. But if it is your own workstation somewhere, then why not? It saves a lot of time, actually. When you are doing some visual debugging, you just try to find some problem, and visualizing problem is a way to go. Let's now do a 10-minute break, I believe. So we are working like 50 minutes, talking, doing something, 10 minutes break. So please have a break. Okay, let's start. So first of all, I would like you to open Canvas to find your group and let's say shuffle in groups, sit together, simply because it will be needed a little bit later. And it would be better just to sit together. So once again, in Canvas, you are shuffled in groups. You just need to find where this shuffling happened for group called Computer Lab #1 grouping, and just please take your seats together closer and so those who do not have group because they're registered for course late, please just join any group and then write me email what is the number of group. So again, those who registered for course just yesterday and did not have any group assigned, you just join any group and write me an email with number of group. I will just manually put you inside. So for all the people who just came back, we're shuffling into groups. You need to find your groups in Canvas. So first thing we need to do is just to get terminal or shell. In the announcement, you found several ways to do it. Sorry? No problem. Some students are missing today. Although they registered, they're missing because they wrote me an email Some people are ill, some people have to go through medical checkup. They are forced to go through medical checkup by educational office and by government. And once again, I am not putting pressure on any of you. If your group just submits something which makes sense, you are getting full point. So, okay, let's probably start and other people will find the groups. Yes, please. Group 8. Group 8? No group. You're a single person, sorry. Sorry? If you're afraid and your first time, just join any group and write me the mail and you'll find it as Group 14. 14. 9? Group 9. Group 9. Last, you can join any group and then just write me an email that you switched to your group. Okay, so first of all of us, we need to get access to certain shell, to certain Linux distribution as a playground. One of the possible ways is to just not to install anything on your site, but to register on Docker. And then you will get, so I believe everyone who didn't have access to terminal did it. Other possible way is to have something on your local machine. So we go to Docker. We need to download Docker. And as you see, there is anything, any system. And then inside Docker, not even inside Docker, but you open terminal. I don't know how you do it on, you know what? I will run my own Docker. If you have already Linux, no need to do anything. No need to do anything. I'm just talking to people who are using their Mac OS or Windows operating system. So I have installed Docker. Here on Docker, I have something which is graphical. So dashboard. Here it is. Here I can look for some remote repositories. Okay. Probably I can find some Alpine Linux here. Nope, it is. So you need to register with Docker, then sign in. Just do not use your Skaltech email. Use some remote image, Ubuntu, for example, and it will be here. It is an image, but Docker runs everything in containers. It makes copy of image, simply speaking, and then you play with it. This is your local copy. And this is a container. Here, then you can run your container, run container, open in terminal. That's it. You have something. So I believe you cannot see anything, but I don't know how to make this large, this screen large, to be honest. But it doesn't matter that much. You can do everything through just Docker. But you need some additional space. And of course, you need to register with Docker. Other way is not to download anything, but to register with Docker when login. I believe I put a link to this website and start. Here we just create something that we are not aware of. So we just get some access to something. Wow, we have terminal. And as usually, we're afraid of something black. Here I will try to make it large. Wow, it just broke. Okay, I believe you see. Now we just need to understand where we are. Uname minus A. What we see here, it is information about our distribution. It tells us what is the operating system, it is Linux. As you see, what is the name of the workstation or remote server? It is just node 1. What is the version of kernel? 4.4, okay. And some other additional stuff. For example, when it was compiled and so on. But we would like to know more. What is the system? Every system, every Linux distribution has its own package manager. So let's find out what is the operating system. It is here. We see Alpine Linux. So this is sort of Linux, which is like minimal working example. This kind of Linux is meant for just playground with minimal size in gigabytes. So if you would like to ship your software, some people choose Alpine Linux simply because it has most reduced size, so smallest possible image. Okay, then I just know that Alpine Linux package manager Alpine. Okay, APK, Alpine Package Keeper. This is how it is called. And you can call it APK. Okay, I found some information how to install certain things. Okay, APK, this is it. Yes, and I get some output. I got some output on what are the parameters. Well, what can I do with it? Let's do, for example, manual. So there are certain commands in terminal, like change directory, which is standard. What is your current working directory? What is the list of files? So you will have to learn these commands. They're very simple, like listing is ls. We have nothing here. But if we add more parameters, we see some very long. We have file system, which tells us some file name or folder directory name that starts with just dot. Are there any problems reading it? Is it visible? Okay, so if we have something that starts with dot, then it is hidden. It shall be hidden. That's why when I typed first command, ls list files, it just showed me nothing, simply because we have everything that starts with dots. Everything is hidden. But as we add more parameters, we're telling, please show me everything, even hidden files. Now we see that it has some git config, which is hidden file that holds configuration for your git that we will be working later. I do not know exactly what is this input.rc, but this is some also configuration for something, I believe, related to standard input. Dot profile, let's cut dot profile. Cut simply shows you entire file, prints it. Okay, we see here some comments and this profile. It is executed every time you log in. So on Linux, in your home folder, you have either .profile or .bashrc or .z profile. It depends on your shell. So shell is not simply whatever you see here. There are different shells: sh, zsh, bash, csh. So let me type it. So shell, okay, csh, not found, tcsh, not found, bash, also found, but we actually executed, and zsh, not here. Let's get out. How many times did I get in bash and sh? Okay. So every such shell program, it has its own, let's say, advantages and disadvantages. They are slightly different. And usually standard is bash. You can find it in Ubuntu, for example, but on macOS, they forced to switch to ZSH. So probably there are some legal problems. I do not know, but we are forced to switch on macOS to ZSH. But for us, it doesn't matter. So in the .profile, every time you log in, your shell just executes this script. I do not know what this PS1 means, but we see that there is alias, which means just when you type vi, you actually type vim, and you execute vim command. Your path, this is where your binaries are looked for. So when you type a command, instead of typing full path, like in Windows, for example, you type just its name. Then this name is substituted in every string in path. So here we have something old. So this way we concatenate strings. We're checking something that was before in path and add something more. So if you have some executable that you put in the folder root go bin, then this executable will be found and no need to find full path. You just have very short name and you're happy with it. Yes. Well, if you let me tell it once again, just everyone can hear it better. So you're asking if you put your scripts in this folder root go bin, then you can execute them. One answer is yes, another answer is no. If you execute them as bash or sh and then short name, then it will not be found because it will look in different folder. It will look only in this current folder. However, if your script is executable, you make it possible to execute. And then just instead of typing sh and then name of script, you just type name of script. It will work. And so we have some, let's repeat this command, cat etc. This is the warning that we actually received when we logged in. You remember it? So I'm scrolling up. This is this warning that we received. So when we logged in, this script, it actually executed. And every time we log in, remotely or locally, this .profile is executed. And you can, why do we need this? We simply put certain variables inside. So just like in normal programming, this shell, it has its own internal variables. And you can choose name of variable, value of variable, and then this variable will persist. It means that you set up, for example, let me put it like that. Echo means just print something, print message. Why do we need it? Very strange command. Why do even people need to print something in the terminal? Simply because you can redirect this. So we put this message, echo, let's echo message. And we append this, we will learn it later. We append it to this /etc or motd. Now we run it once again. Source, etc. Now we see this message. Okay, so we have added echo to So we executed actually this file, and all this. Why didn't happen? Anything for this part where we have hashtags. So it's simply this hash is nothing but a comment. You just say that everything that is inside it is comment. That's why nothing happened, and we see no problem. Okay, what are the comments that we need to learn? It is listing. It lists all the files. And we have here a folder. As we see, it is in different color. And here we have something D, which stands for directory. So here on the left, we have permissions. These permissions tell you whatever you can do and whatever you cannot do. Permissions, first is just something that is saying whatever is the object that you would like to play with. D stands for directory, dash stands for file. There are other options. We are not covering it here, but Linux file system allows different objects to play with. Then we have three symbols, RWX. R stands for read access, W stands for write access, and X stands for execution. It is possible to execute this script. So what can we execute? We can go inside folders. So for folders, it doesn't matter that much. How do we play with all this? Why do we need so long string for all the restrictions and access patterns? So we have three different setups. One setup of these three letters is for user only. So user who created file, for the owner of file or directory. Other three are for all those users who are in the same group. So we have not only users that are standalone users, but groups of users. For example, we have group of users with low access, or we have users who are admins. So we have different groups, users, admins, for example, or some other stuff. And you can belong to different groups, and depending on that, you can delete or change different things. And all the other three permissions, they stand for all users. Okay, so we can play with it. So as you see, for this git config file, only read access, we give read access for all the users. Anyone can read our config, but only people within our group and only I myself can change it. While for the bash history, for the history of commands, nobody can take a look at history of my commands. So it's this is how we work with security issues. You just tell who can get access to which files. They can see that you have such a file, but others, they just do not have access to it, except for root user. Root user can do anything because it's just admin, root, someone who installed everything, and someone who has full access to the hardware and so on. So for this, you can do anything. So this is listing files. Now we can take a look what is the inside. As I've been typing, cat stands for concatenate, and we cat, let's take a look at this input RC. It starts with dot. So here, if we type tab, it just autocomplete for you. So all these different shell scripts or the shell environments. Yes, please. D stands for directory. So here, when we list files, all the files, everything on the file system is just some sort of object. And we need to describe this object. D stands for directory. It means that there is certain data. I don't know how to describe it. It is whatever we see, how it is implemented in terms of driver for the hardware, driver for the file system. I cannot tell you. I'm not looking inside. It just tells me that this is directory. So now we cat file. Oh, we have many different things. I believe that whatever I see here is just to play with input, so with my keyboard. It understands somehow that I'm on Mac. It understands that I'm on Mac from browser because it gives such information to the Play with Docker website. And then depending on that, it enables certain input keyboard shortcuts or changing whatever I input on my side, changing it to corresponding input on the remote side. So there are different kinds of files. And yes, so cat is the one program that we would like to play with. Let us actually take a look at all the executables that we have here. All the executables align, for example, in user bin. So as you see, we have lots of some executable files here. We even have GCC, which stands for GNU compiler, GNU C compiler, and G++ stands for GNU C++ compiler. So we already have compilers inside. We have sort command, for example. It sorts your input. Let's play with it a little bit. Sort 1, 2, 3. And then don't remember. Let's play it like that. We will learn these things later. Okay. So sort simply takes your strings, stream of strings, and sorts it. Okay, so what is the file system here on Linux? We have root directory. So it is just one simple backslash, and we have different folders. Bin here stands for binaries, and usually you are not changing it. It is just Linux provided binaries. Dev stands for devices. What is inside? Oh, we have TTY is just your terminal. So terminal is also a device, and all the interactions that are happening through TTY, through this input, I believe. Okay, let's not touch it. I don't know what exactly it means here. And we have, as you see here, std in, std out, and stdr. So these are standard input, standard output, and standard errors. Where do we play with this? Normally, when we execute a terminal command, it takes something, reads something from standard input, just keyboard input, and outputs to standard output. All the messages and so on. So everything here, what you see, is printed to standard output. And there is additionally standard error. And this is a file descriptor, let's call it like that, that outputs errors. If your command tries to print error, then you would like this error to be just printed immediately. What is the difference between std out and stdr? They both print such that user can read result. But difference is std out is buffered. It means that it collects many outputs that your program outputs in a certain buffer. And then when buffer is flushed, you see all the output. STDR just does not use this buffer. It immediately prints you error and you see it. So when you write a program, it is preferred to output errors to this standard error. Okay, we have many devices, and devices regarding your hard drives, they are also here in /dev devices. Okay, let's take a look whatever we have here. etc contains configurations. Lots of configurations. You see here input.rc that we saw in our home folder. We can take a look at fstab. It is file system. So you see we have device CD-ROM and device USB disk. They are mounted in some way, mounted with help of their read-only. I do not remember exactly what this 0 means, but you can actually take a look at manual pages of fstub. Okay, we need to install man here, manual. No such package. Okay, apk search man. This is, so on Ubuntu you have apt package manager. On Alpine you have Alpine package keeper. This is how it is called, Alpine package keeper. I believe that the main difference is that it has significantly reduced executable size and so on. So now we take a look at where is exactly man. Okay, we have man. Here it is, man.db. So we have installed package, and now we try to find whatever we're trying to play with man. So I just use up arrow. Sorry? I don't like these scrolls here. I don't know how to remove it. Probably like that. Yes, so. man-db, this is how this package is called. So apt actually that you can have in Ubuntu is much more understandable to me. I use it much more compared to APK, and there is delay when you type. So man-db. Well, on Ubuntu, you have different name for man, first of all. Second, it is usually installed. Here, it is not installed. And it could be that we need to do apk update at first. So apk update, as you see, it just collects, it fetches all the information about packages, indexes, it collects indexes. And then you can try again. Okay, it's already installed. So let's take a look at, oh, okay. I do not know exactly how to install it here. Seems like let's just install everything that I see with manuals. And now, no entry. Okay, I cannot find proper name of database that contains here on APK manual for ls command, which is standard. Let's, if you're on unknown environment, first of all, you need to understand what is the distribution, such that you can understand what is the package manager, because sometimes you have possibility to install certain packages. Yes, please. Yes, I can use ls --help, but I was thinking about manual, because manual is where you look usually. Of course, there is for every command, or nearly every command on terminal, if you type --help, you're getting some information, lots of information, how to launch your executable. So list directories contents. This is your usage. That's it, not much information. And then you have all the possible one column output and A, include names starting with dot. So speaking about special names, once again, everything that starts with dot is special and it is hidden by default. Dot is just dot without anything. It is the same folder where you stand. So let's go to .ssh and then we say ls without anything. We have certain files. If we do ls, okay, dot, we're trying to list all the files within this folder because dot stands for current folder. And if we use double dot, it is actually a folder above. So we change cd means change directory, just like with, I don't know, Windows. If you were using terminal in Windows, but it doesn't matter. So commands that you need to learn: list files, change directory, create directory, make dir, make directory. Let's box bxo. Okay. Now we see that we have additional file, which is accessible by everyone, let's say, at least for reading and executing everything inside. And we see that it was created today, but time is okay. There is time difference simply because these servers, they're not in Russia and their time is this 7 a.m. So we go to our bxo folder. Once again, when you type tab, you get auto-completion. And here we create new files. For example, touch file1.txt. It just creates an empty file. That's it. Or if such file exists, touch simply change timestamp. It says, okay, file was changed. Sometimes you need it. And file1.txt is just empty. Nothing here. We can create several files in a single command. It's like touch, let's say, other 123 from 123.txt. Very strange command, but here it's just created 3 files, other 1, other 2, and other 3. So there are ways to have loops. In a single command, you can create many things and play with it. So you will have such a exercise later to create many files, delete many files, find them. But now we would like to change permissions such that some file can be, for example, executable. How do we change permissions? It is change mod modification, and let's say +x means make it executable. Let's make file 1. Okay, we need space. File1.txt. File 1. Okay. Now, when we try to list all the files, file 1 changed color, green now, as you see. And now we have this X, X, and X here. So everyone can execute it. Everyone can execute such file. If this file is just a script, it will do certain steps. Then this is the way to make your script executable. You can actually limit usage of the script to yourself only. Change modification. This is where I never played with, like user plus X other 1.txt and ls minus LA. Now we see that other one is executable only by us, only by the owner. And if we make it, let's say, group plus X, everyone in your group. So other 2 is now executable by not you, but group, other users belonging to the same group. In a similar way, you can change owner of a file. Sometimes it is needed because in Docker, it is standard that you are root user. Root user is bad. being root user is bad because you can destroy everything. But since you are inside Docker and you are in a copy of something, it doesn't matter. You can just delete everything and then create new container out of the same image. Image will be unchanged. It will be copied into container and you will have just new copy of everything. And you won't have these files and so on. So we know how to create directories. We know how to change, how to make your scripts executable, but sometimes we need to delete something. So it is just remove rm. This way we can remove, let's say, other three. And once again, list files. So other three is not existent here anymore. However, once you try to remove directory, of course, you shall not be inside directory when you try to remove it. We go outside. So cd double dot means go one level up in hierarchy. And then we delete. So rm, try to delete this bxo folder. It tells us that this is a directory. So let's find out how to remove directory. So you type ----hell, but I was thinking of doing manual man rm. However, I could not install it here properly. So we see here f never prompt and -r recursive. So probably when you remove file, you need to remove not only directory, but all the contents. That's why we type -r recursive. Okay. What is now? So we don't have this folder anymore. This folder is gone. Let's create an empty, once again, an empty folder. So folder is created. And let's try to remove it again. Once again, it tells us that this is directory. But actually to remove directories, there is separate command, rmdir. Just like make directory, remove directory. But it will only delete empty directories. So if you would like to delete entire tree of files, you need to use recursive option for the rm. Okay, let's take a look at other things. So there are many commands in terminal. At first glance, they seems like too many of them. But these tools like listing, changing directories, removing something, changing date of some file, you will just use it so many times that you will learn it, I would say, in one day. Very easy thing. Once you start actually working. So file system is really nice here because everything starts with root directory and then goes inside. There are different devices there in their own directory. And if you would like to get access to whatever is inside device, hardware, hard drive, you need to mount it. You mount it and you tell this is your directory. So we have this file, folders media. Media CD-ROM. Nothing inside. And the same in USB. So, however, if you have some hard drive, you will see all the things inside. You just need to tell what is the file system. Here it is fed, so you can connect to your Windows system and change it. If it is NTFS, it is not so easy because NTFS is proprietary, requires proprietary driver, which is closed source. You have to install it yourself, do something, and it is not so easy. Okay, sorry. Def SDA, SDA1, SDAB, they're just your hard drives. that I was talking about. You need to mount this hard drive to some folder and take a look what is inside. Here we have nothing because we are in virtualization inside virtualization. So it's like Docker inside Docker. This is what we are playing with here. So what are the good comments that we need to play with? Okay, we have command to find files. So find, it just lists you all files. You know what, let's have 10-minute break now. We have 10-minute break now. And after that, we start doing certain exercises together. And you will post your results to another Yandex form. I believe it is also available right now. You just tell what is your group number, what is your result, what is your single line comment. So idea of all this course is just to make you not afraid of terminal. So, and now you can have your break. So let us continue. So I've been told that PDFs that are uploaded in Canvas, they have unclickable links. So I will upload docx file. I hope that there you can open all those links. So now we are going through, let's say, practical part where I would like all of you to actually do tasks and submit your one-line comment, for example, or set of comments into form. So we have I believe it shall be published. So we have lecture 1 practical session, this form. Interesting. It is very interesting. This is exactly the same link. This is what you shall see. And let me open this link once again. Yes, it opens. So here you type your group number, what is the problem number, and what is your answer. Just a quick feedback form. So where is the document? Here it is. So you need to find what is your system package manager, installed package Figlet. As you let me make it large. Oh, how to scroll? Okay. Is this readable? So you can download this list of problems from Canvas on your local machine. So yes, it is readable. So let's say you have 5 minutes to understand what is your, first of all, to create play with Docker instance, to understand what is your package manager, but we already went through it. It is APK, Alpine Package Keeper, and then install Figlet and try to run this command Figlet hello Ubuntu, and then remove package. Yes, please. All of them are available in Canvas. In files, they're available in files. So files, lecture 1, it shall be, sorry, I don't understand why it is not, it shall be already published actually. This is where you get all the PDFs with course introduction, with lecture material, and you have additional supplementary material to play with your Docker instance and so on, and computer lab PDF. So I will add additionally lecture1.docx where links will be clickable. I hope so. Yes. You shall submit one answer for entire team. So all of you, you try to play with your local instance of Docker, for example, play with Docker. Or if you are on Ubuntu, then you play with your own Ubuntu system. If you are with Windows WSL, whatever it stands for, I believe that this doesn't work. Exactly this, because Figlet, I don't know what is the system package manager for the WSL, to be honest. So in this case, in this scenario, please register with Docker and then create instance of labs of play with Docker and do the task. So we're doing these tasks, then I present how to do it in play with Docker. Yes. No, not number, not number. Comments, comments, instance. Yes, yes. So here in this exercise, you're just trying to install some package, which you know, you're not trying to find this package. You install it, you use it, and then you delete it. If you provide output of comments, that would be nice. So let me just ignore this problem. I mean, I will show how to do it, but later we will play with single line comments. That would be much more interesting. So we need to install package Figlet. So where is my play with Docker? Here it is. So APK search Figlet. Let's find it. Where is such package of this version? And there is documentation for it. So let's add APK add Figlet. Okay. There is some problem with input. Add Figlet. But this time I'm not going to print hello Ubuntu, but hello Alpine. Here it is. Nice ASCII art. And now we delete it. So we do APK minus my dash dash help or man APK, but here I could not install it properly. So del APK del. This is the option that we need. And package name is Figlet. And tab doesn't work, tab completion. That's it. It is not here. Let's check that it is not here. Figlet. Okay. So it is not here anymore. So second task. You need to create 10 files, template it like file number .txt with a single command. I already presented it, but you could use Google or Yandex to search for the answer, type it, and just take a look with listing to see that you actually created it. So you create files with touch command, and with help of ls minus la, you see all these files. If you, let's say, if you fail this, not a problem. I'm not pushing you because here everything is fast. So I've been told that all the comments appearing fast, disappearing fast. I understand. you will have to practice yourself with such commands, going through these exercises, let's say twice or 3 times, then you will remember more or less, because practice makes perfect. And when you see command for first time, nobody would remember it. So as a software developer, you could use how to sort. You could, let's say, search on Yandex, how to sort in Ubuntu files, how to print something in files, how to something. This way you just learn it by practice. You will see a command, you try it, it doesn't work because the system is different, you update it and so on. So we are doing problem number 2. We're creating 10 files, and if it is possible, next command is to delete files. You can either use, okay, we will take a look at 2 ways how to delete files with help of rm command and with help of find command. We didn't go through find command that much, but this is very good command that you will have to learn. Okay, for some reason, group number 2, problem number 3, please do not go that fast. Group number 2. Let's start with first part of this task. So we would like to create 10 files named file number from 1 to 10 with a single command. Let me find Docker playground. So we have nothing here. Let's create empty folder for now. Go inside. So we create mkdir, we create folder empty. We change directory, such we have nothing here. pwd print working directory. There is good command what is, but for some reason it doesn't work properly in this Alpine Linux. What is command tells you what the command does and so on, if you would like to understand properly. Okay, I'm in empty folder. Task is to create 10 files named file 1.txt, file 2.txt, and so on until file 10.txt. So touch creates empty file, does nothing else. When we type file, then special bracket that just tells us that this is a sequence from 1 to 10. .txt. And with help of ls, all these comments, they appear in the supplementary material. So later you could take a look and understand all these comments. Just please play with these comments yourself. So we have all these files created. First task is done, first part of task. Yes. No. Let me try my own Ubuntu. So I have installed Docker. I have I'm running. I cannot make it large. I can make it large. Okay. Let's make empty tier here. Oh, I forgot to create it. We go to empty tier. We list nothing else. Touch. So it works, not like that. Okay, I understand. Here it is, you have to launch bash. Seems like shell terminal, this terminal that you're working with, it does not support this syntax. So you have to launch bash. So what I did, this is what you see when you launch Ubuntu Docker. You need to type bash, press enter. Now you're in bash terminal and it supports all this stuff. So base shell doesn't support this fancy stuff, unfortunately. Yes. Are you talking about command here in Docker, in my own Docker? I type bash. And this way I launch this shell terminal, and this shell terminal simply supports many different syntaxes that allows single command to be expanded in a very nice way. This such that I have all the files created. Okay, second part is to remove files. Okay, let me take a look at all the answers. So I see that most of groups are still in stage number 1. So, I mean, stage number 2 is not solved yet. So we're solving it. No need to, I'm not pushing you. You need to, let's say, go through it once again, take a look at the supplementary material in Canvas, and then try to solve these problems by yourself, or try to find someone who will give you a command, you will type it, but practice makes perfect. You need to, let's say, Google for it, type it, and see how it works. So now we are removing. Let me just open once again comment. We need to search files with a number 4 to 6. Okay, so we're looking for files named file 4, file 5, and file 6.txt, and we would like to remove them. So there are 2 ways. One is with a rem command, just like with touch. So we can do such thing, ls file. Yes, there are such files. And using the same syntax, we can remove them. Just a rem, remove. And now we take a look. Between file 3 and file 7, everything is missing. Now we touch it back, create them back, and try to find them. So find tool, it helps us find files. So find, it just lists all the files here. Oh, we have many things. So what we do, find here, and we would like to have name, file.txt. So you see command find looks here in this current folder, files with name, this parameter, that matches this wildcard. So we have file, then star stands for anything, and then .txt. So we have all the file 7, file 4, and so on. We are not listing here files, but actually we'll list it here, just digits. They are not listed with the help of our find command. Now we would like to reduce amount of things that we see. For example, does it work? No, it doesn't work. We need to find how it works. Here it is. This is the command. This is magic command. What you see here in brackets is regular expression. We will study them more next time. But for now you can Google for an answer how to select subset of files and remove them. So we found these files, how to remove them. Minus delete, that's it. No such files anymore. Do we see them? No. Find command can do many things. And your goal would be, with this computer lab, would be to practice it a lot. You will have to find certain files, matching criteria, and so on. Most of your work would be not based on whatever I tell you here, but looking for an answer on Stack Overflow, for example, trying to get all the information out of it, simply because time here is not enough to study all of these command line tools. So it is up to you, it is your homework to find answers, to share them. For example, you can split work in your team, in your group. Everyone looks for certain answer when you share answers, and then everyone just types these answers, walks through the answer, and so on. So we have deleted these files 2 ways. So we solved second problem in 2 ways. Second part, we have deleted files with help of rm command, just like we created files. And then we used find command for this. So item number 3. You need to list contents of your current directory and put or output everything into a single file. Here you need to look for pipeline, for example, how to redirect standard output to a file in Linux. This is what you need to search for. Yes. So once again, idea of this task is for you to try to look for answers on the web. Then try this answer on your local or probably remote terminal. And if something doesn't work, try to understand why it doesn't work. And if it works, just repeat the same step just to learn how this command works, because this command find will help you a lot. And you have to go through it yourself. Without practice, you will forget it easily. And first steps with find command are not so easy. I understand you. I was also not using it. I was using simple stuff for finding files. I was mostly writing Python script to find files that match certain criteria and so on. But this tool is much faster. Redirecting can be done with help of a simple symbol. Greater sign. It just redirects standard output. The first time it is really hard to understand, but you have to launch it many times. For example, let's find files from 1 to 3.txt and output into contents.txt. This is the command that lists, first of all, first part of this command. It lists all the files here in this current in the current tree, starting with the current folder, that matches this pattern, which stands for file 1.txt, file 2.txt, and file 3.txt. And then this is just redirect standard output to a file called contents.txt. We see no output of this command, but if we take a look inside, we call cat of contents.txt, which stands for concatenate contents.txt. We see all these files. They are in some order. If we would like to do something with that, we could sort, we could do other stuff with help of command line tools. So we have found certain files, but they do not include ownership. To get ownership information, we need to use ls command. So, okay, now we see these files. And for every file that we found, we can do execute certain command. For example, ls-la. This bracket stands for just substitute whatever was provided by command find. No, without this, sorry. So now we see that for file 3.txt that was found first, we just do listing. It is better, yes. So we list everything, including permissions. So this file can be read by anyone in our group, by anyone else, flag, and this read write is for us. So I understand that it is not so easy for those who just try it for first time, but please take a look at video once again. Later I will upload it and follow these commands, or ask someone who is more experienced, or try to use the web to find answers. Ideally, these tasks, they just meant here to make you. There are other comments how to take a look at what is inside file. You will see it more in supplementary material. It's like tail, which stands for print last, rows, head, print first, rows. So there are many comments that you have to learn by practice. Yes, please. Okay, let's do last thing. Count number of files starting with file within your home directory. So home directory, it is, you can use any directory actually. So for this task, you need to, first of all, with help of command find, list all the files that match this criteria that start with file, that have prefix file. And then with help of other command, for example, so what I did not show you properly is so-called pipeline, when output of one command is an input for another command. This is what you have to learn, this way or other way. And so let's show how this pipeline can work. First, one of the possible commands is, let's say, so we have contents.txt file. How can we pass its contents to some other command? This is done with help of this just line. This is meant for pipelining. So output, something that comes into standard output of previous command, serves as standard input for the next command. For example, ls. Sorry. Okay, these comments and ls, they not taking these arguments. So there is command word count, wc word count, and then you just whatever you would like to count. Help, so it tells you -c bytes, so it counts how many bytes you have in your standard input, or m how many characters, or -l lines. Usually we use number of lines. So for this last task, you need to find how many files that have this match this that have file as prefix in your folder, in any folder. So we just do find, for example, in the root folder, this is where we're looking for minus name and file star, which this is a wildcard. It looks for all the files that match this pattern. They start with file, then anything else. Or we see many files. We see lots of files. So you see, it just counts files also on my own installation. So verify in this Docker instance, in this container, I have connected Docker to my folder, which contains my code with my programs. And then it just goes inside and looks for all these files. So this is, let's say, not safe for me to do anything with these files. So I will try to find in home. Okay, maybe in root. Okay, we're in empty. So you see, we have found all the files that match this criteria. Now we would like to count how many files. For this, we can use this command wc-l, which takes standard input, for example, line 1, 2, 3, 4. Okay, once again, 1, 2, 3. And it outputs 4 lines. Probably it's better to do this way. A, B, C, D, F. When I press Ctrl D to stop this input. And you see that I have 4 lines. It means that output of this command, I need to redirect, not through a file, but through pipe. So there is temporary file that is hidden from you, and all the output is redirected to this command. So something that is output of this command becomes input of this command. And we have 9. So we have 9 lines here. Totally, we found 9 files. Would we like to do anything with that? Then we can, let's say, so there are many commands, and we will learn it by practice. Any questions? So all the other things are for your personal practice. So you need to look for web for answers. Play with Docker or your own Docker installation, and just get experience with it. You need to get practice with commands, practice it several times, do very dumb stuff. You need to just create files with given pattern, then look for files with given pattern, try to look for files that do not match this pattern. There are many options. So we have find -- help, and then you have this long help, which is actually not very long here. And the manual is not available on my Docker for some reason, because it is minimalized. Okay, I would like to finish our lecture for today. I understand that you have many questions, lots of practical things, hard to understand. You have to go through practical exercises. So this computer labs or homeworks is the only way to learn this. It doesn't matter how fast or slow I am here. You have to type everything by your hands. Your hands have to learn. Yes, please. So I did put a week deadline. So starting from today, you will see everything in the canvas, but for me, it doesn't matter that much. We could, let's say, prolong this. I don't know what is the deadline for your pass or fail state. So last week is for you working on projects. So I believe you have to, for this point, when you are working on projects, you already know how some of these commands work. I am not asking you to remember by heart how find works. I just ask you to understand that if you want to find something, you use this tool. If you want to alter certain files or find files that match certain pattern, which command you have to use. That's it. Everything else can be searched for. You can use manuals or whatever. This is the idea, not to be afraid of terminal. Once again, for the project, gather up, find your teammates, find a project. I mean, some old repository, some old code that you are working with that have very bad, very old way of compiling everything. I mean, just you provide shell script that compiles everything for you, for example, or you're using Microsoft Visual Studio that does everything for you. But then you will have to port your code to Linux. This is the idea. Try to find some of your old code and try to improve it in the end. So, okay, thank you. Six and eight are the same. Really? There is a mistake here. It should be. Yes, yes. No, you don't have to do all these tasks now. There is 1 week for you, and probably it will be prolonged, but please learn it. I mean, please go through it when you have free time. So what we should do about just post, since it is like that, just post whatever is here. If you would like to change it to depth number 2, then okay.